In the first video, we defined an agent as a model plus a harness, then placed the agentic loop at its center. I'm Mehrdad, and now I want to open up the rest of that system and show you what sits around the loop. We will name 8 recurring components, understand their 2 jobs, and build one map we can reuse throughout this series. Different agents may implement these parts differently, but the underlying anatomy changes far less than most people expect. What made this architecture click for me was seeing the same shortlist inside very different production agents. Open Claude Code, Cursor, Codex, or an agent your own team built, and the implementations can look completely different. Underneath, you still find context management, memory or state, tools, checks, and constraints performing the same essential jobs. Once we recognize those jobs, each new agent stops looking like a completely new architecture we must learn from scratch. The central claim is that every harness is built from the same components, even when their implementations vary dramatically. Each component can become a substantial system. Context may include retrieval and compaction, while verification may include tests, evaluators, and retry logic. But the architecture is not a fresh design each time. The same 8 components surround one loop, with different depth depending on the task, risk, and operating environment. Learn this map once, and the remaining videos become deeper examinations of responsibilities you can recognize across frameworks. At the center is the agentic loop from the previous video. Gather, act, and verify before deciding what happens next. Every surrounding component performs one of 2 jobs, either feeding that loop or bounding how it operates. Context, memory, tools and routing, and skills feed the loop with information, capability, and procedural know-how. Verification, guardrails and safety, observability, and governance bound the loop by checking, constraining, explaining, and authorizing its actions. Feeding does not mean uncontrolled input, and bounding does not mean blocking useful work. Both sides make each turn useful and controlled. The first 4 components give the model what it needs to choose and execute a good next step. Context is what it sees this turn: the goal, instructions, retrieved evidence, tool results, and a compact account of earlier work. Memory is what it keeps across turns or sessions, with policies for what to extract, consolidate, and recall. Tools and routing define what it can do, then select the right action and destination for the current need. Skills describe how it does the work by loading tested procedural know-how on demand. Together, what it sees, what it keeps, what it can do, and how it does it. The other 4 components keep the loop correct, safe, explainable, and accountable while it takes real actions. Verification asks whether the step is right by checking a real signal, then deciding whether to continue or retry. Guardrails and safety ask whether inputs, tool calls, and outputs are allowed at the moment they occur. Observability shows what happened through traces, metrics, latency, cost, and the specific step that broke the run. Governance defines who may act, what an agent may act as, and which actions require approval or an audit record. These responsibilities overlap, but they are not interchangeable. A trace can reveal an unsafe call. It cannot prevent that call. This map becomes most useful when we stop treating it as a taxonomy and start using it as a debugging checklist. An agent may loop without progress, forget its goal, call the wrong tool, or take an unsafe action. The easy conclusion is that the model is not smart enough, but production failures often point somewhere else. Check whether verification measured progress, memory preserved the right state, routing distinguished similar tools, or a boundary lacked a guardrail, walking the 8 turns, a vague complaint about intelligence into a specific question. Which component is absent? Too thin or badly connected? This component view is also appearing across recent research, where different groups separate harnesses into nearly the same recurring responsibilities. One formal definition uses execution loop, tools, context, state, lifecycle, and evaluation as its 6-part harness tuple. A layered taxonomy, sometimes shortened to ETC-LOVG, covers similar ground while promoting observability and governance into explicit layers. You do not need to memorize either taxonomy. Their value here is the convergence across independently developed descriptions. This map turns that convergence into 8 operational components, including skills as the newest first-class addition. The map matters even more when several agents collaborate, because copied components create duplicated infrastructure and inconsistent behavior. If 5 agents each own separate memory, tool lists, and guardrail logic, we now have 5 harnesses that can drift differently. A better design often shares the components that require consistency, such as one memory service, routing layer, guardrail policy, and observability model. Agent-specific context and permissions can remain separate wherever roles genuinely differ, rather than forcing everything into one global object. Make sharing and separation explicit, and the map stops sitting around the system. It starts running the system. Carry 3 ideas forward from this anatomy of a harness. First, every harness uses a short recurring list of 8 components rather than a completely new architecture for each agent. Second, 4 components feed the loop, while 4 bound it so each turn remains useful, correct, and safe. Third, the same map is a debugging checklist. When an agent fails, find the component that is missing, too thin, or badly connected. That is the map we will reuse as we examine every part of the harness in greater depth. If this series is useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. Next is video 4, Single Agent versus Multi-Agent Systems, when one agent is enough and when it is not. I'll see you there.